All right. I heard someone mention extra credit, and I haven't looked at it in a while. So if you've done it and it's not scored, I'll get to work on those. I forget it's still there. If you haven't, um, it'll I think it'll help you to connect the various things with trig. Let's see. Actually, we've had the formula sheet all along. So if you go into the final, yeah, it's showing final exam review. If you go to the final exam review, this module here, just so you can kind of look ahead. See if it loads up. So you see this is the formula sheet that will be provided with the final exam. So there's a unit circle that you of course, it's not all completed for you, so you do need to know how to complete it, but you'll see all these formulas that we're using today. We're going to do the double angle formulas, the half angle formulas, and there's some power reducing formulas, but they don't really use them, so I don't think there's any in the homework. But today we're going to focus on these double angle and the half angle. And again, those are there. It's also an announcement in Canvas where I just posted the one sheet. So if you want to take that, print it out, maybe while you do the homework, it might be nice to have it there because you know you're going to have that during the final exam. The other thing it does is since that's what you're going to get on the final, you start to locate, your mind starts to locate where different things are. You get used, as you use that, it's going to be easier to use on the final if you've used it before. Because even if we just give you all the same stuff but scramble them, it's going to be harder for you to recognize it. But we won't. We'll give you that same sheet. So it gets some consistency. All right. Any questions or concerns or things that I've missed as we go through things? Doing okay? All right. So we're getting close to the end. So we're going to do the double angle, the power reducing, and the half angle formulas. After that, we have trigonometric equations, and then sines and cosines. So 3 units, but as I told you, I'm going to combine sines and the law of sines and cosines because they really are doing the same purpose. It just we're solving triangles for either the 3 sides, their lengths, or the 3 angles, or both. And with those last things, we can do it for everything. So we'll kind of tie those together, still have some time for review as we go through. Okay, so double angle. Get into our slide deck. And again, I'm really will just consist of presenting the formulas and then going through some examples of how they're used. And that's all trig, so trig is pretty compact. You've got the basics, the foundations for trig as far as angles and adjacent over hypotenuse, all those sorts of things. And then now we will, okay, I forgot to change the cover page, but I'll go back and do that. So it is the right slide deck, just has the wrong title. This isn't supposed to show up first. It's supposed to give you the double angle formulas. So these are double angles. So it's x plus x, right? So we could do this with the sum formulas, but they become specialized because there's 2 angles, but they're both the same size, if you want to think of it that way. Or it's 2 times the angle. Either way, we come up with some formulas over here. Let's get my writing utensils again. By the way, if you think you're having a tough day, I had an exam in my first class. I got halfway here driving and I realized I left the exams at home. So I had to turn around and go back. And so it's like one of these days. I don't know that I want to start it over, but maybe just skip it. But anyway, hope your day's going better. So we've got these formulas. So there's one for sine, that if you have a double angle, 2 times the angle, or think of it 2 of the same size angles, that we can evaluate it with this formula over here. Now, if we have an angle, we could just multiply it by 2 and calculate that new angle. Okay, but sometimes the way we're given it, we don't actually have the angle, but we have something else, and so we can use the formulas. Or sometimes we see the other side of the formula and we can do it the other way. So a lot of this is, remember, it's a circle, and so there's circular reasoning, and sometimes you use one or the other or both sides. Okay, cosine has actually 3 different versions that we can use, again, using the Pythagorean identities as well. So we've got all these identities, and remember, each of these formulas is identical. It does the same thing. They look different, but they will give us the same values. And so a lot of times, that's why we give them to you as we work through problems. We look at, these are all the tools I have. Which one should I use for this particular problem? Yes, yeah. So that's what we're going to do. I don't think we do anything with tangent, but there's a formula here for it if we need it. So let's start with the first example. We have this expression, 2 sine of 22.5 cosine of 22.5. Well, we could plug that into our calculator, but if we want an exact value, we don't have a special angle that's 22.5. But what you do notice, hopefully, is that this is, and notice I kind of put the examples here so we don't have to flip back and forth. That's 2 times sine of an angle, cosine of an angle, the same angle. Doesn't that look a lot like this? Yes, it does. Sine of x, cosine of x. X is the same thing. So we get 22.5 and 22.5 are the same thing. What we're able to do is we're able to rewrite this, that this is also equal to sine of 2 times that angle. Now, this is a very contrived thing. What's 2 times 22.5? 45. One of our special angles. So this comes from the unit circle, right? So this is really 2 times that. So that's just the sine of 45 degrees. And what's the sine of 45 degrees? It's in the first quadrant, right? So, so sine is going to be the y value. It's just square root of 2 over 2. So we can do it. Again, very contrived, but sometimes we don't have one of our special angles, but this, allows us to get those. And again, all we're doing is we're looking at formulas, seeing what we've used and what can make it easier. So a lot of this is kind of like puzzling or problem solving. I realize how much space I had, so let me write a little bit smaller. Square root of 2 over 2. Okay, change colors to blue. So now we're asked to verify this identity. 2 sine squared theta plus cosine of 2 theta equals 1. You see a sine squared theta, maybe if we could get a cosine squared theta or something, that's what we're looking for. Because we know, hopefully, we remember there is a special formula. But basically, we need to get remember when we verify, we take the left-hand side and we start using other identities to rewrite it till we get the right-hand side. So we're trying to rewrite this to be equal to 1. So we've got 2 of sine squared. Here's a 2 sine squared. Minus 1 equals cosine of, or we could go with cosine of 2x and go with one of these two, right? Which way do you want to go? Looking at those, what kind of a replacement or substitution do you see working? Let's focus on this. What could we replace cosine of 2 theta with that might get us closer to what we want to do? We have 3 choices. I'll label them A, B, and C. Which one do you think we should use? How many vote for A? How many vote for B? How many vote for C? Okay, we've got a few more for C. You could try the other ones and it wouldn't be wrong, but you'll see it might not be helpful. The reason C looks promising is there's this 2 sine squared, and notice this is a minus 2 sine squared. We can get maybe get those to cancel, not maybe, but we will. And then maybe we get closer to 1 equals 1. So let's try this. So we've got this 2 sine squared, so we're just rewriting what we have to 2 sine squared theta. And now this is where we're going to replace cosine of 2 theta with this one. And again, you could use either one of them. It's not wrong. But if we do this, we get 1 minus 2 sine squared theta. So, you know, we could use the x or we could use theta. And now we're not, and when we verify, we're trying to get, we just worked one side. So we're working the left side until it looks like the right side. We've got this parentheses, so this sort of but do we need that parentheses? We just have a plus here, so the plus would distribute, right? Plus, and that's 1, plus times a negative, still negative. And so now we could combine like terms. And as we combine like terms, what happens? Positive 2 sine x minus 2 sine x, those cancel. What's left? 1. Does 1 equal 1? It does. Okay, see how it works. But if you didn't choose that at the beginning, try that other thing and you'll say, oh, it's not getting any nicer. Maybe I try something else. So that's what happens with these is when you're doing the homework, unless you've done it before, it's unlikely that you will pick the right one the first time. Occasionally we do, we get lucky. But don't feel so bad. It's part of it is choosing the wrong one. As you work through it, you'll see, oh, I see why that's the wrong one. I'll do this one. And you'll get this rhythm that when you choose the right one, they typically will simplify fairly easily, fairly straightforwardly. If they're not, step back. So this is a problem. So, you know, again, how many of you are trying to be engineers? Almost 100% of you, right? So that's why you're taking this particular class. And that's what you have to do with engineering. Sometimes you're in this problem and it's not working. Sometimes it's better to start over and rethink and try something else. Sometimes maybe you were close. Okay, so, but that's what these are going to do for us. So there's example 2. Now this one we might have to go back and forth on. This one's a little more complicated. So we're asked to find sine of 2x, cosine of 2x, and tangent of 2x. And notice we're going to use these formulas here. And we are given that secant x equals 3, and that our angle x is in quadrant 4. Okay, so what do we do first? Maybe we come back here, we look at sine 2x is 2 sine of x cosine. So maybe if we knew what sine of x and cosine of x was, we could do this. Same thing if cosine of 2x, it's going to break down to, let's see, cosine squared or sine squared. And tangent of 2x breaks down to tangent x and tangent squared. So what we can do is we can take this information and remember, if we know one of the trig functions, thinking in terms of, we can build the triangle, opposite over hypotenuse type stuff, right? So let's build that triangle. We know it's in the fourth quadrant. So we know our triangle is something like this. We don't know what the angle is, and we probably never will because we don't have to. But we do know that secant x equals 1 over 3. What does that mean? Secant x is 1 over cosine. So we also know 1 over cosine x equals 3. So what would cosine x be equal to? 1/3. So there's this thing, if you've got two fractions that are equal, if you reciprocal of both of them, you'll get the same thing. So cosine of x over 1 is equal to 1 over 3. So 1/3. Cosine, what is the sides that we can use? What's the ratio sides? Cosine is in terms of adjacent, opposite, and hypotenuse. So adjacent over hypotenuse. So adjacent side is 1, hypotenuse side is 3. We can figure out the third side. Okay, so if we have one trig function, what it's equal to, we can always build a triangle. And that's typically what we will do. What's this third side? Well, Pythagorean theorem, 3 squared equals 1 squared plus, that would be the opposite side, squared. So that's 9. 1 squared is 1. We subtract that. Gives us the opposite side squared. 9 minus 1 is 8. Take the square root of both sides. So square root of 8 is the square root of 8, but remember there's a 4 times 2 in there. What's the square root of 4? Square root of 4 is 2, so we can write this as 2 square root of 2. Okay, and because a lot of times they want the exact value, so that's its exact value. This side is 2 square root of 2. Or square root of 8. I mean, you still get the same value, but they might want you to simplify it. So we've got our three sides, adjacent, hypotenuse, and opposite side. And so what will be the sine of x? Sine of x is opposite over hypotenuse. Opposite is 2 square root of 2. Hypotenuse is 3. We've already got the cosine, right? We solved that. That's here. We could write it up here again. Cosine of x is 1/3. And then tangent is opposite over adjacent, right? Notice how we come back to those foundational building blocks of trigonometry. Opposite is square root of 2 over, or 2 square root of 2, 2 square root of 2. Adjacent is 1. So we could just write that as 2 square root of 2. Thank you. Okay. So we've got our three sort of single angle values now. We go look at the double angle formulas, we write them out, and then we replace them with what we need. So let's start with sine of 2x. And we don't have to memorize this, but if we can, I think it's 2 times the sine of x cosine of x, I think. But I'm going to go check it. I have to go back. 2 sine x cosine x. So sine of 2x equals that. And that's what I mean is have that formula sheet sitting next to you while you work through things. Okay. And so now it's just a sort of the substitution. What is sine x? Well, there's sine x. So this becomes 2 times 2 square root of 2 over 3 Cosine x is 1/3. It's 1/3. And so we just multiply the, oh, sorry. Oh, geez, I forgot completely about that. Thank you. Yes, awesome. And I even drew the picture and I forgot about all that. So yeah, it's one of those days. Just okay. So what's negative? Just the y, the opposite side would be negative, right? Because that's the fourth quadrant. First quadrant's going to be. So thank you so much. We'll make it nice and bright red. So sine is going to be negative. We got to make that negative. Cosine is still positive, so we're okay with that. Tangent, though, is going to be negative because, right, it's a negative over a positive. This we could just write as -2 square root of 2. Okay. Thank you. Thank you. Okay, and so we multiply straight across. We got a positive, a negative, and a positive, so we know our final answer is going to be negative. 2 times 2 is 4. So we get 4 square root of 2 times 1. So 4 square root of 2. And in the bottom, we get 3 times 3, which is 9. See how that works? So we kind of went off on a tangent to figure out what the triangle was, and always figure out what quadrant you're in. Easy to forget about, but important not to forget about it. Get our values for sine x, cosine x, tangent x, and then we can use the formulas. We're just replacing them with those values. Notice how we never know what that angle is. We don't really care. Well, maybe we care, but we don't need it for whatever. We just need to know the values. So we good with that so far? Okay, now we're going to have the right answers. And incidentally, all of these are in the notes, which obviously I didn't read, otherwise I would have caught that. But so you can go back and look at these. They're worked sort of step by step through the notes that are also in there. I just took the examples and said, let's work through them. And actually, when you make mistakes, sometimes you learn more than if you don't, because you'll remember to check it next time. Okay, cosine of 2x, right? Now, we have 3 different versions that we could use, right? We go back, we could use either one of these. We could use cosine squared minus sine squared. We could use this, we could use that. And this one, it doesn't really matter. Anyone have a preference for which one you'd like to see? A, B, or C? And this time I'll take whoever speaks up first. And we'll get it right either one we use. There's no wrong one to use. A. Okay, just go with the first one. All right. Cosine squared minus sine squared. That's kind of easier. It's hard to mess that one up, right? The other ones I might mess up. So, so this also, oh, I was going to mess it up. Cosine minus sine. Cosine squared. Now I'm going to write this differently. What cosine squared is really cosine x squared, the whole thing squared. Okay, so even though we write it on the cosine and then put the x, what that really means is find the cosine x and then square that value. Okay, same thing with the sine. It's really sine x all squared. Otherwise, you kind of, where do I put that square on, right? So what is cosine x? Let's change colors, maybe to green. Cosine x is 1/3 and it's positive. So we're going to square that. What is sine x? It's -2 square root of 2 over 3. And we're going to square that. And then we subtract the 2. Okay. So 1/3 squared is going to be 1/9, right? Square the top and the bottom. Then we're going to subtract. We're going to square the top and square the bottom. So 2 square root of 2 squared, right? You get 2 times 2 is 4. Square root of 2 times square root of 2 is 2. 2 times 4 is 8. So the numerator in a negative becomes positive. So this just becomes 8. And remember, we started off with that was the square root of 8. Sometimes, to me, I would have preferred just leave it like that, because what's the square root of 8? What's square root of 8 squared? It's 8. A lot easier to do. But for some reason, people like to, mathematicians like to change it. So that's 8, and the denominator squared is 9, so that's kind of cool. We have 1/9 minus 8/9, which gives us 1 minus 8. Anyone going to help me with that one? Thank you. Okay. Negative 7/9. Now, what does that mean? Cosine is negative 7/9. I thought we were in the fourth quadrant. But are we in the fourth quadrant anymore? We were in the fourth quadrant, but we multiplied that angle by 2. So where are we? We're probably, again, depends upon the size of the angle, but we're easily either in the second or the third quadrant now, because we're doing a double angle. So you got to kind of think this. But how many of you, when I saw me put that negative, thought I was wrong? I did. I thought, oh, maybe I did something wrong, right? Because we're in the fourth quadrant, it should be positive. But remember, we're doing a double angle. So a fourth quadrant angle, you multiply it by 2. We're no longer in the fourth quadrant. Double the angle is no longer the fourth quadrant. Just try like 300. Where you double it, you got 600. Where is the 600 minus 3? That's actually in quadrant 3. Try it a little bit, but you sort of lose some of your feelings here, because again, we don't know quite where we are, because we don't know exactly the angle. Is that good though? Okay, so just be prepared. You may get a different sign on your answer because we got a double angle, right? And when we do the half angles, remember, we might have started in quadrant 2 or 3, but if you take half that angle, we might be in the first quadrant. So we're actually moving to different quadrants. Okay, so far so good. What do we have left? Tangent. So let me, this is all sort of my work here. I think I can remove it. Again, it's still in the video, so you can always back it up if you wanted to see how we got to these. But we've got everything up there. And so now I want the tangent of 2x. Let's see, let's go like this. And again, it all starts with getting a formula. There's only one formula, so we really only have one choice for this. It's going to be 2 tan x over 1 minus tan x squared. Okay, so we kind of remember what we got. Forgot what we got. Okay. It becomes 2 tan x over 1 minus tan x. And again, I'm going to write it in the way we actually use it. It's the whole tan x squared. Okay, so we plug what tan x is and square it. So far, we good? And notice I didn't start with the derivation of, you could actually come up with all these formulas by using other identities. But what I find is if you learn by doing these things, then if you had to go back and derive them, it makes sense. But anyway, so what is, so let's see. Here's a tan x, there's a tan x. We're going to replace it with negative 2 square root of 2. Or remember, that's negative square root of 8 if we want, so when we square it. So what we get is 2 times negative 2 square root of 2 all over 1 minus negative 2 square root of 2 squared. Okay, so we plug in the things we know. Now it's just arithmetic, right? calculations. 2 times negative 2 square root of 2 is going to be negative 4 square root of 2. In the denominator, we're going to square this first. And so, again, we're going to get think of it as 8, square root of 8 is the easiest way to think it. When you take the square, you square the square root of 8, right? So we're thinking this is negative square root of 8 squared. Awesome. You're welcome. And so if you take the square root of 8 and you square it, what do you end up with? 8, right? Actually, and it was negative, but when we square something, that goes away as well. So this is just going to be 1 minus 8. Did I get that right? Okay. Good. We're not quite done. Just finish it off. 1 minus 8, negative 7. A negative and a negative become a positive, so our final answer is 4 square root of 2 over 7. And again, we ended up with a positive answer, but we're thinking it's a tangent, right? We're thinking we're in the fourth quadrant, but we're no longer in the fourth quadrant because 2 times that, we're probably now in the third quadrant, right? Because tangent is both x and y are negative, and we can kind of see that, right? We got a negative sign, we've got a negative cosine, and a positive tangent. So we could kind of locate, oh, we must be in the third quadrant now. So double that angle, put us over into the third quadrant. But that's the thing I always mess up with the double angles, is I'm thinking, wait, we were in the fourth quadrant. But remember, we're multiplying that angle by 2, so we're someplace else. And when we do the half angle, we'll also be somewhere else. We'll be half of what angle we're at. Make sense? Okay, so with these, you're going to pull back to our foundational stuff of triangles and opposite and hypotenuse and adjacent sides and that SOHCAHTOA, right? That's kind of our foundation. Sine is SOHCAHTOA. Opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent, adjacent, no, opposite over adjacent. Okay, so those are the kind of things you need. And that's really, trig comes down to having a fairly good memory on, at least on the basics. Okay, and then we can move forward. Ready for half the angles? Should be half as easy, right? Oh, half as hard. One of the two, I don't know. Okay. Don't even got good jokes today, so we'll try. What are the power reducing and half angle formulas? So I don't think we actually end up using these, but what they're doing is you could go through and derive these. So sine squared could also be thought of using these other double angle formulas. And then if you solve them, notice how the half angle formula is these power formulas. So sine x squared is really just the square root. So they don't have, I didn't see any examples or any homework where you're using these power sine squared function, but they introduce the half angle formulas by talking about these first, and that if you just take the square root, you get them. So that gives us an indication of how they came up with these formulas. Okay. And then again, it's a lot of algebra, trigonometry identities in algebra to come up with these particular formulas here. But once we have them, you take the square root of both sides, and again, it's not necessarily completely obvious, but that's what you end up with. So the half angle formulas, sine of x over 2, all we really need to know is what cosine of x is. We plug it into this formula, we got it. Okay. Cosine, all we do is plug it into this formula, so cosine x. And look at tan x. So the half angle formulas, what do we need to know? Just cosine x, and we can get all the half angle formulas. Okay. That's kind of cool, isn't it? I think it is. I'm sure. So, like I said, half the problem, maybe less than half the problems, because the other ones we had all these different angles, and we had no sine and cosine and tangent for these for the double angle formulas, right? This one, we just know cosine x, we're good to go. That last problem, we could have just found cosine x equals 1/3. We would have been done. Boom, boom, boom. So, yes. Good question. That's where the harder part is, and we'll do an example. We'll do an example. I think is the best way to go about this. So, sine of pi over 12. Should we use a half angle or a double angle formula? Well, if we think that this angle is double of something, what are we talking about? We're talking about pi over 24. Do we know anything that's pi over 24? Awesome, thank you. Pi over 24. That's not even better, is it? But if it was a half angle formula, so if we're thinking this is half of some other angle, what is pi over 12 half of? It's equal to 1/2 of some angle. Multiply both sides by 2, right? Two goes into 12 6 times. We're at pi over 6. Hey, isn't pi over 6 like one of our angles? Yes, it's one of our special angles. So this is how you do it, is you kind of figure out how do we get to our special angles. Remember, we really only have 3 of them. We have pi over 3, pi over 6, pi over 4, pi over 3. 30 degrees, 45 degrees, 60 degrees. Those are our bread and butter. So we're trying to make those. That's how we kind of tell. So that's telling us, let's use a half angle formula, that the pi over 12 is half of pi over 6. And so if we know what the cosine of pi over 6 is, remember that's, and then pi over 12 is half that, we're home free. Do we know what cosine of pi over 6 is? We should, from our unit circle, right? Unit circle, that's 30 degrees. 30 degrees. What's the cosine of 30 degrees? Should have that. Square root of 3 over 2. Good. So remember, the square root of 3 over 2, square root of 2 over 2, square root of 1 over 2, or 1/2, right? So that's how cosine goes. It's those. Sine goes in the other opposite. It's 1/2, 1 over 2, square root of 2 over 2, square root of 3 over 2. So it's those are the values we need to see. Just kind of tick them out, and we're good. So if we remember square root of 3, square root of, no, that's right, square root of 3 over 2. That's what cosine of x is going to be. Okay, so we're going to do this as the sine of pi over 6 over 2, right? Because we have a formula for sine of x over 2 is equal to 1 minus cosine x over 2. Square root of that. So the x is pi over 6, right? Because pi over 6 divided by 2 becomes pi over 12. So it's just a rewriting of pi over 12. Does that make sense? And if it doesn't, let me know, and I can maybe work through it, tell you it's a fraction in the numerator, fraction in the bottom. You end up multiplying the denominator. So 6 times 2 is 12. Kind of what we did over here. That pi over 12 is half of some angle. That angle is pi over 6. And so we use this formula. And we're going to get plus or minus. There's always this plus or minus because it was gotten by a square root. It's going to be 1 minus the cosine of x. Cosine of pi over 6 is square root of 3 over 2. all over 2, and that's all inside the square root. So let's simplify this. In the numerator, we have a number and we have a fraction. To be able to combine those, we need a common denominator, right? What's the common denominator? 2. So we want to think of 1 as being 2 over 2. Two minus square root of 3. We can't do much other than that. And we could sort of drop the plus or minus because what quadrant are we in? Pi over 12. First quadrant. Sign's going to be positive in that first quadrant, so we can, from that, 2 minus 3 over square root of 2 divided by 2. What do we end up with? 2 minus square root of 3 over 2 divided by 2, which, divided by 2, that's 2 over 1. You flip and multiply, so that's 2 minus square root of 3 over 2 times 1/2. 2 square root of 3. I've got a square root over this whole thing. Over 4. Square root inside of a square root, but it's what we got. It's our exact answer. And again, so you see, we're going to have to work with fractions and fractions over fractions and square roots and those kind of things. So sometimes those are the most difficult part of the whole thing, because we don't directly necessarily cover them. Supposed to know all that stuff from so many years ago. But notice we were able to actually come up with this exact value for sine of pi over 12, right? What we've got is sine. We can come up with an exact value of 2 square root of 3 over 4. Did I do all of that? Oops, no. 2 minus. Got a little sloppy. And okay. Now there was another way we did the pi over 12. We could also do it with the sum and difference angles, but we will get the same. We will get the same value. So far, so good. More complicated one. But we're given cosine of alpha, given that it's square root of 2 over 3. It's not one of the special angles, but we're just told this. What does this thing here tell us about the angle alpha? It doesn't tell us what alpha is, but it does tell us, where is it? Fourth quadrant. Okay, good. So this tells us we are in the fourth quadrant. So that will help us to the signs, whether our answers are positive or negative. We've got the sine of this angle of beta. And again, beta, though, is not in the fourth quadrant. It is in, wait a minute. This is a leftover slide from Tuesday. We did this on Tuesday. Thank you. That's good. Maybe because I took that same presentation and then I thought I deleted all the slides, but we don't need to do. We did this on Tuesday, so that's in that video. It might be okay. Here we go. This is the one we want to do. That's going. What? There's no half angles here. Okay. So, and also they gave us the cosine. I was going. They gave us the cosine. That's going to be real easy if those were the half angles, but Notice they never make it too easy on us. They're not giving us the cosine, they're giving us the sine. So what are we going to have to do to be able to use the half angle formulas? We need to find the cosine. So we got to set up our little triangle, and what we're given is opposite over hypotenuse. We need to find the adjacent side, and it's still good. This tells us what quadrant are we in. That looks like third quadrant, right? Bigger than pi, but less than 3 pi over 2. So we're in the third quadrant. So, and we've given the sine, but remember from all the formulas, we need cosine. So we're going to set up our triangle in the third quadrant. And we know the opposite over hypotenuse. The hypotenuse is 7. The opposite side is square root of 13. Since we're in the third quadrant, that's negative. See, notice how I made a big mistake in the beginning, but now I'm going to remember not to make that mistake. We're in third quadrant. We got that. We just need to know the adjacent side. So adjacent side is going to be 7 squared equals negative square root of 13 squared plus the adjacent squared. 7 squared is 49. Square root of 13 squared is 13. The negative becomes positive, but we have to subtract it over onto this side. So 49 minus 13 is equal to the adjacent squared. 49 minus 13 is 36. Oh, that's a nice number. Did I get that right? Is it 36? I was going, it's going to be too good to be true because the square root of 36 is square root is 6. So our adjacent side is 6. So we put that there. So what is our cosine? Again, that's all we need. Cosine is going to be cosine of x is adjacent over hypotenuse, which is going to be 6 over 7. Thank you. Almost, yeah. So I told you I got too confident. I thought I was cured. It's negative. It's negative. Thank you. That's why I got you guys watching my back, right? Okay, we good? All right, so now we've got what we need. That's all we need. We don't need the sine of, well, we got the sine of it. We don't need the tangent of it, but that's all we need. And now we go to the formulas. Sine of pi over 2, or theta over 2, sorry, is going to be sine of x, or actually I guess we should say sine of theta, since that's what they're using, is like from the last time, the square root of 1 minus the cosine of theta over 2, plus or minus, since we are in the third quadrant, sine is going to be negative. Well, wait a minute. Sine of theta is in the third quadrant. If we're in the third quadrant and we take half that angle, where are we? We're either in the second or the first quadrant, right? Depending upon, like if you're at pi, half of pi would be pi over 2. So actually we're in the second quadrant if you cut it in half. We're at 3 pi over 2. We're at 3 pi over 4, which is also in the second quadrant. So sine, the half angle, is actually going to be in the second quadrant, so it's going to be positive. Okay. And so let's do this. Is going to be 1 minus negative 6 over 7. Again, because that's theta, cosine of the angle theta, which we're told is in the third quadrant. All over 2, square root. We get a negative and a negative, which will make a positive. We've got 6/7 So we need a common denominator. Let's write 1 as 7 over 7 plus 6 over 7 all over 2. 6 plus, or 7 plus 6 is 13 over 7 over 2. And so when you've got a fraction in the numerator over just a single denominator, the denominators end up multiplying. So 7 times 2 gives us a square root of 13 over 14. And it should be positive because our angle theta is in the third quadrant, but half of that angle is going to put it into the second quadrant, right? So what we do is the half angle, we divide everything by 2. Theta over 2 is going to be somewhere between pi over 2 and 3 pi over 4. 3 pi over 4 is less than pi, so it's wholly, completely in the second quadrant. Okay, so we okay with that? Okay. Cosine of theta over 2. Again, we just back up and we're looking for this formula. So it's very similar, except it's a plus instead of a minus. Okay, so see how these half angles kind of grow on you. They're a little bit easier to use. So it's the same formula, but a plus instead of a minus. So we're going to get the square root of 1 plus negative 6 over 7 over 2. So it stays negative, so we're taking 1, we're rewriting that as 7 over 7. We're going to subtract 6 over 7, all divided by 2, square root. 7 minus 6 is 1/7 over 2, and so that's going to give us 1/14 square root, and this will be negative because we're in the second quadrant and it's a cosine. Okay, so that's, watch your signs on these, your plus or minus signs. Does that make sense? Okay. And finally, tangent. Always run out of room, but fortunately I can erase parts that, we figured out the 6 part here. We don't need to use this so much anymore. And again, it's all recorded in the video. So let's go with green, and tangent of theta over 2. And remember, theta over 2 is going to be in the second quadrant, so that's going to be a cosine's negative, sine's positive, tangent's going to be negative, right, because of ratio. So we know it's going to be negative. We back up to the formulas. This is the one we want to use now. So 1 minus cosine over 1 plus cosine. One minus cosine, cosine is negative 6 over 7. 1 plus cosine. Did I get that right? Negative and plus, okay. Negative and plus, negative in the top, plus in the bottom. So remember, 1 is just 7 over 7 as far as a fraction. Negative and negative become plus, so we get plus 6/7 here. In the denominator, we get 1 minus, or sorry, we write 1 as 7 over 7. Becomes 1 minus 6/7. This whole square root. So in the top, we're going to get 7 plus 6 is 13 over 7. In the denominator, we're going to get 7 minus 6, which is 1/7. And when you've got a fraction over a fraction, you flip the bottom one and multiply them. Okay, so this gives us 13/7. Flip the bottom, 7 over 1. Square root of all of this, 7, 7, cancel. We're going to get square root of 13, and let's see, it's all negative. So sometimes I leave off. Should have been carrying it along. So tangent, the exact value for that tangent of that angle would be negative square root of 13. Okay, so what you just got to, you don't have to memorize these formulas. They will be given to you throughout the exams and everything. So again, print it out, put it next to you, or put it on your phone as a picture. Just be able to refer back to them because they're helpful in helping you work through the problems of knowing where you want to go. And then remember, we'll be given an angle sometimes, or the quadrant of the angle, but we've got to think, if we double that angle, where are we? Or if we take half of that angle, where are we? So we're going to be in a different quadrant either way, most likely. Only one is if we're in the first quadrant, you take half of that angle, you're still in the first quadrant. But you can, the other quadrants, if you take half that angle, you'll very well be in a different quadrant. And when you multiply it by 2, you're very likely to be in a different quadrant. So you've got to work through that. And those different quadrants tell you whether you're sine, cosine, tangent, whether you've got a plus, a minus, plus or minus, right? But the half angle, again, we need to know the cosine of the angle. If we know that, we can figure it all out. The double angles, we need to know the cosine, the sine, and the tangent. We've got to figure all 3 of them out to be able to get all those angles. But if we're working with sine or cosine, there's all those different ones there. And I gave myself extra room. I didn't need it. So that was the last one. We don't have to worry about this one. I'll delete it from the slide deck because I almost did it again. But the main thing for the lesson today is these are our double angle formulas. So again, use them as we did. And then we've got really the half angle formulas. The other ones were used to get the half angle formulas. Okay. Awesome. Next week, we start, and it's a one-day week, right, for us because of Thanksgiving. Some folks may be traveling. Again, we'll record it. You take a look at it. But we're going to be solving trigonometric equations. So we may have to come back. Sometimes we'll get them to solve them algebraically. We're going to have to come back to some of these formulas, these identities, to rewrite them differently. The other advantage we have with the equations, though, when we're solving equations, we could actually graph them, and the solution will be where they intersect. So we'll have some technology to help us know whether we're on the right track or not, but we'll also be using all these different formulas, all these different identities that we have as well. And then after that, we'll solve some triangles, and which we've already kind of done, and then we're kind of done for the course. So the week after Thanksgiving, we've got one, maybe a day and a half of new stuff with the law of sines and cosines. My plan is to do it all in one day, and then that gives us a day for review. And then the week after that, we've got our final exam. So it's coming up. All right. Thank you so much. Hang out for any questions you might have, and we'll be good.